So here we have two equations again. It says determine an explicit equation for each composite function below, then state its domain. So g of f of x. Well, f of x is 1 over x plus 3. And then g of x says whatever you plug into g of x, you square it, then you minus 4 times it, because it's x squared minus 4x. So wherever there's an x in g of x, since we're plugging in 1 over x plus 3, wherever there was an x, we replace it with a 1 over x plus 3. So there was an x squared, so now I have 1 over x plus 3 squared. And then it says minus 4x, so now I have a minus 1 over 4 times 1 over x plus 3. And then it says state the domain. First of all, can you look at this and say, yeah, this is not going to be an easy one to graph? We could. We would have to write it as a single fraction and use our skills from chapter 2 with rational equations with an x on the top and x on the bottom to figure that out. But it doesn't ask us to graph it, it's just asking us for the domain. So another strategy for figuring out the domain is to think, are there any x values that are not possible? The only value that isn't possible is x can't equal negative 3. Because if you would do that, that would cause you to divide by 0. But everything else is fine. And you could see that x could not equal negative 3 already at this point, right at the beginning. Because if you plugged in negative 3 right at the beginning, you would have a problem. So when we're checking our domain, we're not only checking our explicit equation in the end, we're also checking for non-permissible values early on, which is in the beginning when it first gets put into g of x. So we are going to, the one I want to do for practice for this is 6D, but I would like to do that one together. So I am going to pull that up right now. So 6D, that is on page 317, right? Where is it? And for each of these it says we want an explicit equation for the composite function, and then we want to state the domain. So here we want to do f of x. I don't know why they use this. No. So this is interesting because they give you g of x. I thought maybe they gave you the same f of x and g of x for a, b, c, and d, but they don't. They're different ones. And do we need g of x at all? No. So that is part of the question where they give you extra information that is of no help whatsoever. They could also tell you h of x is equal to smiley face. That wouldn't help either. So we have extra information in this function that we don't need. We only need to use f of x. And the rule for f of x is that we have 1 over x minus 1. That's what f of x equals. So now, and the reason I wanted to do this one together is sometimes with fractions, it can throw you off a little bit. But we have to remember the basic idea that our f of x function says whatever you put in, what happens to that? You do 1 over whatever you put in minus 1. So now we have a fraction, 1 over x minus 1, inside our function. So whatever we put in, this is going to equal 1 over, can you see the highlighted x here? Instead of that x, I have to write 1 over x minus 1 minus 1. Now, this right now is called a complex fraction because we have a fraction inside of a fraction. For your final exam, you're not allowed to write final answers as a complex fraction. You have to take this and write it as a single fraction. And for that, you're going to use a lot of the skills that we also used in our identities unit. How do we deal with fractions over fractions? We try to get a single fraction on the top, and we try to get a single fraction on the bottom, because then we have a fraction divided by a fraction, and you can multiply by the reciprocal. Can you see that on the top of our fraction, we already have a single fraction? We could call the top 1 over 1. But on the bottom of our fraction, we have 1 over x minus 1 minus 1. And in order to put that together, how do I subtract fractions? What do I need? A common denominator. So I'm going to multiply my 1 by x minus 1 over x minus 1 to get that common denominator. And then once I have that common denominator, what is the top going to equal? Because the bottom is all going to be x minus 1. I'm going to have 1 minus x. And this is where we make a lot of mistakes, because this subtracting is subtracting all of this, so it has to get distributed. So it'll be 1 minus x plus 1. And now I have a fraction on the top and a fraction on the bottom. I can multiply by the reciprocal, and when I simplify this, it's going to be minus x plus 2. And so the question now is, what is our domain? Well, we could take this and use our rational Chapter 2 unit to graph that, and that might help us figure out our domain. But part of graphing that would be saying, are there any non-permissible values? Would I ever divide by 0? Yes. X can't equal 2. Now I'm going to highlight that in light blue. That's a problem. So our domain is x can't equal 2. But the reason I wanted to do this one together is there's another value that's not allowed. And you can't see it in your final answer. But if you look back through your whole work, are you ever dividing by another thing that might cause you to divide by 0? Right, here. Or you might even be able to say here, right at the beginning. There's lots of places where we are dividing by x minus 1. So another value that is not allowed in our domain is x can't equal 1 either. So that one's tricky, because if you just look at your final answer, you're going to miss the x can't equal 1. And so when looking for non-permissible values, you're going to look through your entire equation for things that aren't allowed. And the main things that we look for in these questions is dividing by 0, but we will also get some square root equations, and you know that you can't take the square root of a negative. So throughout your whole equation, you're going to be looking, do I ever have square roots? Because then I can't have negatives inside of them. Am I ever dividing by a variable? Because I can't divide by 0. And then our domain is everything except 2 and except 1.